Okay, now we're recording, I think. Okay, so we just put that 3x minus 5 in for x. Okay, the second one, remember, g of f of x means the same thing as g composed of f of x, like that. So either one of those mean the same thing. And this time, what do? I put f into g, right? So I take g right here, which is 3 times x minus 5. And where the x went, I put parentheses, and I'm going to put x plus 4 over 2 in for that one. That's the, we put function f into function g. I wrote that backwards down here. Oh, wait, no, that's the next problem down. F plus g. Okay, I was looking at the wrong one. All right, so if we simplify this one right here, you guys, you know, there's a couple different things we could do, but I would probably just leave this. I mean, we could divide the 2 into each of these, like Sarah was saying earlier, and we could just go 3 times x over 2, so this is going to be 3 halves x, and then 4 divided by 2 is 2 times the 3 is 6, and then we're going to minus the 5, right? And so we get 3x over 2 plus 1. Did anybody get that? Okay, good. You could write that as 3x plus 2 over 2 as well. Did anybody get 3x plus 2 quantity divided by 2? All right. Now I got to do f plus g, f minus g, and f times g. This is a little bit easier. So we have, what we're going to do is add these together. Should we divide the 2 into each one of those terms? Well, let's write f as 1 half x plus 2, and then we're adding to it 3x minus 5. And so we have 1 half x plus 3x makes what? 3.5 x. How do you write 3.5 x? 7 halves. Okay, good. Is that how you wrote it? 7 halves x. And then 2 plus a negative 5 makes negative 3. How many of you got 7 half x minus 3? Okay, there you go. So that was f plus g. Now we're going to do f minus g. I'm going to move this up. Move these down a little bit. F minus g. What is f minus g? Well, that's the same thing we just had here. We can write 1 half x plus 2 minus 3x minus 5. This one, we have to write the second one in parentheses at least, because I have to distribute the negative through, right? And so I get 1 half x plus 2 minus 3x plus 5, because I distribute a negative 1 through those two, right? And I get 1 half x minus 3x, which is going to leave me with what? Negative 2.5x, right? How do you write negative 2 halves as a fraction? Negative 2 and 1 half. You got the last one, so I just thought maybe you'd get this one. Negative 5 halves, that's right. Negative 5 halves x, and 2 plus 5 is 7. So negative 5 halves x plus 7. Right? Anybody else get that? Raise your hand if you got that. Okay, some of you guys are getting this down. Okay, f times g. F times g, we would have 1 half x plus 2 times 3x minus 5. And we would multiply 1/2 x times 3x. We're going to distribute. 1/2 x times 3x makes 1.5 x. How do you write 1.5 x as a fraction? 3/2 x, right? Squared. Good. Colby. And then 1.5 x times -5. What would that make? -5/2 x? If you put it as a decimal, it would be 2.5x, -2.5x, right? 2 times 3x is 6x, and 2 times -5 is a -10. So we combine like terms, and we get 3/2 x squared. -5/2 x plus 6x, that's -2.5 plus 6 would be 3.5 x. What's 3.5 x again? 7/2 x minus 10. And there's f times g. All right. Those 5 problems you should be able to do. Okay, that's what we learned in the last domain, the last standard we had. Okay? All right. That's how many bell work? Is that our first bell work? All right. So we turned in the bell work last time. All right. Say that again. How do you write what? How do you grade it? Well, if you went through it with me and got them all, I'll give you a 5 out of 5. If you feel like you got it down, okay? All right, 5 out of 5. All right. We had an assignment last time. I'm gonna answer 1 or 2 questions on it, maybe 3, if you have some. How many of you are all done with it? All right. Does anybody have a question on it? Okay, go ahead, Ryan. 23. I love this problem right here. All right. F composed of G composed of H of -2. Okay, so we probably ought to write down F, G, and H. Okay, F of x is, what is F of x? 3x. G of x is what? X plus 4, and H of x is x squared minus 1. All right. All you do on this problem, you guys, is it's saying that it wants us to put -2 in for the function h, and then function h into function g, and then function g into function f. We're just working backwards, so it's kind of like this. -2 into h into g, g into f. You just always work backwards on compositions. And since they gave us the number, -2, instead of giving us x, then it makes it easy. Okay? Because now all I do is I take -2 and I put it into function h. Well, if I do h of -2, that means I got -2 squared minus 1, because h of x is equal to x squared minus 1. We got that? Yeah. Well, -2 squared is what, everybody? 4. Subtract 1, you get? 3. Thank you. Okay. So now all I have to do is take that 3 and put it into function g. Well, function g of 3 is equal to 3 plus 4, which is equal to 7. And then all I have to do right there is put 7 into function f. And f of 7 is equal to 3 times 7, which is equal to 21. And there is my answer. Sarah. Yes. Okay, did you hear that? That's another way to do it. Okay. You go G. What was that? Sarah's way will work. And it's a great way. The only problem is it's probably a little bit more work, isn't it? Yeah. Because you have to actually work with the x's the whole time until the very end. Then you get to put the number in, -2 in. So, but Sarah just put function h into function g into function f, and then at the end put -2 in for all of it, okay? That's what she's saying. I like doing it this way better. It makes it a little less complicated because you don't have to work with all the x's. Okay, but you can do it whichever way you want. Okay? All right. Are there any other questions on that assignment? Okay. You sure? I'll do number 11 because I did get a lot of questions on it. Number 11. G of x equals x minus 6, and h of x equals x plus 6, and we're supposed to find g composed of h, and then h composed of g. Now, I'm kind of shortening it. I'm not putting the x on the end, you guys, but it's the same thing. All right. What is this one saying to do, you guys? Putting which function into which one? H and g. Always work backwards, right? H into g. So if I take function g, which is x minus 6, and I plug in x plus 6. Hi, Michaela. What's up? Okay. All right. Well, give me a few minutes. I got to run over to this. I got to run over to the hardware and grab something. Okay. Okay. Then come in. Yeah, let's go look at it. All right. X plus 6. Oh, yeah, that's right. I forgot. I have that on, don't I? X plus 6 minus 6 is what? X. And then if I do h composed of g, which function am I putting in which one? G into h. And so I'm going to have function h, which is x plus 6. And I'm going to put function g in there, which is x minus 6. And once again, if I simplify it, I get x. These two functions are compositions of each other are the same, right? Okay, any questions? All right, let's grade this thing. Okay. How many problems did we do right here? Well, wait, didn't I give you... It was 1 and 3. You gave us 1, 3, 9, 11. Yeah, I gave you all the odds except for 5 and 7, isn't that right? Yeah. So that's 10 problems? I want you to know, you guys, you are even with the other class. The had to... Hey, let me tell you what. These guys were working on this still hard when you guys were all done. And I'm going to be answering questions for a while. Who told you that, Kylan? Somebody from the class. Well, yeah, give me a name. Don't give any names. All right. Looks like I'm going to have to penalize that class for telling you guys my secrets. All right. I know. I incriminate myself every day in here, don't I? Now. All right. Okay, let's do this. So math 1, 10. We're going to do problem number 5. Which one? The 5th problem. Which one's that? 13. Problem 8, which is... It's 19, isn't it? 19. The 3rd problem, which is 9. The 2nd problem, which is 3. And the 10th problem, which is 23. We should all have 23 for the answer. Okay, Everybody trade papers with your shoulder partner or rotate it with someone else. You guys need to rotate it with Kayla, Colby, and Austin. Okay, you guys got them circled which ones we're doing? Okay, so number 3. What's the answer to number 3, you guys? F plus G. What was F plus G? X squared minus X plus 4, right? And F minus G would be X squared plus X minus 4. And F times G would be X negative X cubed plus 4X squared, right? Or you can go 4X squared minus X cubed. Okay, but I just wrote it in descending order. Okay, what's the next one? We're doing 9. G composed of H. That's going to be 2X plus 4. And then H composed of G would be 2X plus 2, right? Okay, what's the next one? 13. Okay, G composed of H. That would be 5X squared plus 5X minus 5, right? And then it would be 25X squared plus 5X minus 1. What's the next one? 19. 19 would be 8, let's see, 12. 8 plus 4 is 12. Okay, would be 12 and 23. We just did it right there. It is right there. It is 21. Okay, 10 points. 10 points possible. Put a score on it. Huh?
Oh, wait, right there.
Oh, right there. You should ask her. Okay. What? Oh, I'm not going to. You mean the problems we just did? No, I'm not going to show you that. We're going to do something else. All right. Okay. Today, you guys, we will learn how to move graphs of quadratic and absolute value functions. Also, given a graph, we will learn how to write an equation that models it. So, this is what we're going to learn today. We're going to move graphs. You guys are going to learn how to move them. Also, I'm going to be able to write an equation up there, and you guys will be able to. I'm going to put a graph up there, and you guys will be able to find the equation for it. So those two things. Okay, so starting off with, you guys, what kind of function is f of x equals x squared? Quadratic. Everybody graph it into your graphing calculator. Go to y equals, type in x squared, whoops, x squared, and hit zoom, and what? 6. Why? So standard window. I want everybody to have the same window. So we have from -10 to +10 on the x-axis, -10 to +10 on the y-axis. And our scale is 1, meaning it's going up in 1s on both axes. Okay, you guys, this is what we call the parent function of quadratic functions. We call it the parent function because it is the most basic function of a parabola. All other parabolas are what we call transformations of f of x equals x squared. And I want to talk about this name right here, transformation. Today when I wrote the objective, I didn't use this word, but because you guys probably wouldn't understood it if you read that thing. But I want to talk about that word. The transformation is just moving a graph around. Yes. Did you guys hear Colby? The parent function of a linear function is just x. Y equals x, or f of x equals x. Okay, now, what I want you to do, I'm going to give you guys a few minutes to play around with this. I want you guys to figure out, let's say I wanted to move, by the way, where's the vertex right now? 0, comma, 0, right? Does everybody see that? I want you guys to figure out how you would move the vertex to 0, comma 4. Play around on the calculator for a second. I'm going to pause this, see what you come up with. Okay, what did you guys get? Okay, y equals x squared plus 4. Okay? So, do you guys all know how to move it up now? Yeah. Okay? Move it down 3 units from 0, comma 0. Down 3 units. Okay, what did you guys get? Say that again. X squared minus 3. Okay. So, does everybody understand how they're going to move a graph up and down? All you have to do, in your own words, I want you to tell your shoulder partner in your own words what you do to move a graph up or down. Okay? I'll give you 15 seconds. All you do is change the last number. If you told somebody else that, would they understand what you meant? Okay. I'm going to call him Jalee. What did you guys get? You and Shawnee. Yeah, move it up and down. What would you say in your own words? Good. Add or minus a real number. However much you want to move it up or down, right? Okay, guys, this one's called a vertical shift. Write this down in your notes. F of x plus k will shift the graph how far? However much k is, right? Vertical shift will shift the graph k units vertically, right? So if I said k was 7, what would the graph do? Go up 7. If I said k was a negative 5, what would the graph do? It would shift down 5, okay? So everybody knows how to shift a graph vertically. All right, that was the easy one. Now, I want to see if you guys can figure out how to move it horizontally, left and right. Okay? I want you to move it 3 units to the right. 3 units to the right. So your vertex is going to be at 3, comma 0. Shift it 3 units right. I'll give you a few minutes. Okay, Hannah, tell us what you got. What did you get for the answer? What's the equation? So y equals quantity x minus 3 squared, right? Now it shifted to the right 3 units. Okay? How would you shift it to the left 6 units? Left 6 units, everybody. Try it. Left 6 units. So your vertex is at negative 6, comma 0. All right. Okay. What did we get right here, you guys? Colby Neild, what did you get? Huh? Okay, quantity x plus 6 squared. Okay, notice that it's the opposite direction you want to go right here. So on x minus 3, it moved it 3 to the right, and x plus 6 moved it 6 to the left, so it's going to be the opposite. Does anybody know why? Because it's in parentheses. You guys remember in vertex form, it was x minus h squared, quantity squared, and so if If you wanted to shift it to the right, you would replace h with a positive number. If you want to shift to the left, you'd replace it with a negative number. Well, h plus, like if I did this, x plus minus, x minus a negative 6, quantity squared is the same thing as x plus 6 squared. So you really did put a negative 6 in, but it's going to be the opposite of the sign. Okay, so in your own words, how would you explain to somebody how to make a function shift left and right? I'm going to give you 15 seconds to discuss this with your shoulder partner. Describe it in words. Okay, go. Okay, so you guys, here we go. Horizontal shift. Horizontal shift. Okay, if we have f of x plus k, it will shift the function k units horizontally. Okay. By the way, if k is positive, it will shift it to the left. If k is negative, it will shift it to the right in this case, okay? All right, any questions there? Okay, so now you guys got this down. Next question. I want you guys to write an equation where the vertex is at 4, negative 3. 4, negative 3. Write an equation where the vertex is at 4, negative 3. When you got the answer, share it with your shoulder partner. 4, negative 3. Okay, what do we have, you guys? Y equals? Okay, that will move the vertex to 4, negative 3. Well, we already knew this, didn't we? Didn't you guys already know that?
Oh my gosh.
Okay, you already knew that. Okay, everybody close your eyes. Don't look at my calculator. Close your eyes. Don't look. Come on. Don't cheat. It won't be any fun if you cheat. Don't look. Don't look at my board right now. Turn your head. Okay. Are we there yet? Okay, you can look right now. Okay, write the equation for that. Write the equation for that one. 6 left. Raise your hand when you're done. Show me the graph. I want to see the graph of it. Oh, yeah, I got to clear that.
You big dummy.
Whoa!
Were you talking to me, Colby?
You think you can get away with it?
Think you know well, don't you?
Are you still recording?
I've got that on tape, Colby. All right. I don't think it is either. Okay. All right, you guys got this down? All right, so what is it? Y equals what? Plus 3. All right. Okay, you guys got this down. Okay, here we go. Now, I want you guys to put in x squared. And then I want you to put in 2x squared. And then I want you to put in 5x squared. And I want you to graph those. And watch them. Now, when you graph them, they're going to graph in the order you put them in there. Y1, Y2, and then Y3. I want you to look at them as they graph.
Oh my goodness, it's like a rainbow if you turn it upside down. You turn it upside down.
Describe what happened.
Yeah, what's
To,
that?
describe to your shoulder partner what happened.
It starts with L.
Yes. Okay. Cheyenne has got the floor. Kai, Kobe, listen. Cheyenne's going to tell us what happens. What happens? The bigger the number, the skinnier it gets. Would you guys agree with her? Yeah. Okay. By the way, the bigger the number, the skinnier it gets. This is how we would say that. You guys, on number 2, we would say where on y2 where it says 2x squared, we would say it narrows by a factor of 2. And on the third one, we'd say it narrows by a factor of 5. Everybody say that to your shoulder partner. Thank you, Andrea. Okay, wait, Colby and Ryan, I didn't see you guys talk to each other. Tell them what we just said.
They're fighting right now.
All right. Okay, you guys, now, let's see if you guys know how to make it fatter, wider. See if you can know how to make it fatter. I want it to be fatter now. How do you make it fatter? Okay, how many of you figured it out? Raise your hand if you got it figured out. What did you have to do? Andrea said it. You need number 0 to make it, right? The closer to 0 it gets, the fatter it gets. For example, right here, we're going to go down here, and I'm going to go 0.7 x squared, and then I'm going to do 0.2 x squared. Now, which one's going to be fatter? The 0.2, right? There's the 0.7, and there's the 0.2 x squared. The closer to 0 it gets, the fatter it gets. So a number between 0 and 1 is going to do that. F, well, let me write it like this. K times f of x. In other words, if you multiply a function by a number, it will get fatter will get wider K is between 0 will is that correct English? Or is it narrower? More narrower, you guys. Wait, who's a good English person in here? Narrower? All right. It will get, I like that word. It will get thinner. If x, or not x, k, if k is greater than 1. Okay, and you guys, we always say, for example, if I make k 1/2, I would say it gets wider by a factor of 1/2. Or if I times it by 5, I would say it gets more narrow by a factor of k. Thinner by a factor of k. Thank you. Yeah. Just don't let your parents hear this because they might think I don't know how to speak English. So. Okay, but I can do the math.
That's right.
All right. Okay, now, what's the next one? All right. You guys remember? Okay, how do you flip it upside down? No. Oh, you guys all got it. You guys figured that out when you're trying to make it fatter. You put a negative in, huh? Okay. Okay. If I want to make it flip upside down, I'd go negative x squared, right? And it will flip it upside down. Turn your eyes, don't look. Okay, I'll delete it this time. All right. Find the equation for that one. I'm not giving you any hints. I'm not even giving you vertex. If you want to get the vertex, you come up here and count it yourself. Come on, Jaleesa, go for it. Jolie, we need a J person to do it.
Jaywalker. Whoa, I can no longer see the graph.
Two comma negative 4? There you go. Okay, come on, find it. Find the equation of that thing right there.